What's up, ladies and gentlemen? So after all these basic videos, we can finally get into practical stuff. Very starts of making a simple game are here. This series is a walkthrough of process of making the game. Means used here are not the best possible, they are just the ones that get things done. Let's begin. Starting scene. I started by removing non-necessary objects from the scene and grouping other ones. Time-lapse will be playing in background. I move directional light to light game object group. I will be calling empty game objects which serve for organization purposes a group from now on. We create empty game objects by clicking plus icon in hierarchy, empty game object. Then I disable default global volume, post-processing game object that modifies visuals of final render in any frame. And I moved it into group of unused, but if I remember correctly, I just deleted it in the end. And once my mind is peaceful because of clean scene, I added basic plane, one-sided for vertices mesh game object serving as floor for now. Then added 3D capsule which serves as a player visual representation. Grouped floor plane in terrain game object. Added a plane for ramp from which balls will be dropping. For precision rotation we called control Y rotating object. And for precise scene camera position we use widget on top right in scene window. We can set camera to perfectly align with any of axis here. There is also a switch to change between isometric and perspective view in the middle. Isometric view is kind of technical view where distant objects don't get smaller. Top left of scene view there is snapping toggle which I usually keep on. Final setting in this video for it is 10 in every axis. I finished setting up ramp without it though. I duplicate floor which will become one of walls by Ctrl D shortcut. Make group for walls in terrain group. Changing position, rotation and scale of walls and duplicating them to make final walls section. By the way, they are now planes, but I changed them later to be proper 3D shapes for proper collisions. Once basic level setup is done, I change camera to be attached to player capsule and adjust its and player transform to my liking. Transform is short for all three of position, rotation and scale. Once this is done, I drag group game objects to project tab and make them prefabs. Objects I could reuse in other scenes or that can be worked by separate people. However, in solo project of such small scale is just for hobby purposes. I like everything to be prefabbed. Also, prefabs can be worked when any of scenes are open, not only when current scene contains them. I do quick test changing player position in play mode with launch game via editor inspector. Any change we do in play mode does not change the state of anything outside of play mode. Basic input, first code. Then in project settings, player tab, other settings, I change input to use only new input system. It required editor restart. And of course, I never remember details, so I have to internet search for input system setup. You know, internet searching is programmer number 1 skill. Link in description. Added player input component to player game object. Then created first script in project tab plus icon scripting mono behavior script and my scripts folder. Mono behavior is type of script that can be placed on game objects in Unity editor. This is how it looks by default. I delete unnecessary part. This is how very basic C# script looks like. Using Unity Engine or using namespace allows us to use code given namespace contains. Namespace is just a separate group of functionality. This particular using allows us to use anything Unity Engine namespace contains. In this very basic case, mono behavior part below. The next line is public class player input mono behavior. Class is the very foundation of C#. It allows us to write functionality inside of it. Namespace can be a group of classes. Public means it will be visible outside of this file. Colon is how we inherit other classes. Inheritance is basic concept of C# and other object-oriented languages. It means we inherit most of following class after colon. Things that are not inherited are ones which were marked as private. So in this case, inheriting mono behavior allows our code to be used by editor game objects. I made basic method which only displays text in editor console window. It is just a default Unity log. Method of type is void on left. Void means method does not return any value. Return means if it was called in other method, it could be of some type like number and would be expected to give calling method some number after finishing. Then I go back to Unity and it needs to recompile code. Compiling is process of translating code we wrote in C# to do something that computer understands. Now we need to call our simple debug.log method. I add our player input script by dragging to player game object. Naming was unfortunate because now we have input system player input component and our player input component with the same name. I change input system player input component behavior variable to invoke Unity events, which allow us to call C# call by setting it in inspector window. In events variable below there are two subgroups now, player and UI, and they correspond to window you see on the right, project settings, input action maps. In an inspector at jump field we set our script method. Before launching the game I applied changes to prefab because now we were working with scene game objects which can have differences from base prefab. We click play, I press buttons which were set as jump action in input action map by default, space key, and our debug log message appears in console tab. So this is very basic, but our code gets called and it works. Sphere game object and UI. Then I go back to changing scene. I make folder for terrain called layout, not the best name. Move terrain prefabs to this folder. Make new group for obstacles. Add sphere to scene, attach or technical term parent it to obstacles group. Change scale to 5 in all axes. Move it to the top of ramp. F to focus on object. Hold RMP and WASDQE to move around in scene view. Drag and drop sphere to project tab to make it a prefab. I create empty game object for UI, then add text. We need to import TextMesh Pro essential for that. TextMesh Pro is recent upgraded text for UI. It's way better than old text version. We can change display text in text component, duplicate game object by Ctrl D shortcut, move new text by rectangle transfer tool, shortcut T. It's better for precision transfer manipulation and can be used on non-UI as well. I put -1 as value so I know it's not the proper value in case something does not work. After basic UI game object setup, I create C# mono behavior script component in inspector and move it to scripts folder in project tab. Fast time lapse of writing code. Let's pause now. There is a new concept here. Serialize field is C# attribute that is Unity specific. Attributes tell that some variable have special uses. In this case, serialize field tells that variable can be visible in Unity inspector. Middle part tmpro tmp text specifies type of variable. In this case, it's an object from Unity engine namespace of type tmp text. tmp standing for TextMesh Pro. This type is the same that component we saw in Unity inspector recently. Last part is just name of variable. My convention is to have lower dash and then small first letter. Then there are two methods, awake and update. These are specific for Unity. They are called automatically if placed in class inheriting from mono behavior in specific moment. I will link in description documentation on Unity special methods execution order. Awake gets called immediately after mono behavior component is created. Update is called every single game frame of component being enabled. In awake, I place check if serialize field variable was set in inspector. If it wasn't, it would be equal to null as you see in the first line of awake. In this case, program will throw argument null exception and inside brackets, I set message that this exception will write. I set it to be the same as name of variable we check. So if an exception will be thrown, it will send message lower dash text. Why would I write this code? Well, it allows me to see if all my setups are done properly right at the start of a program, so it is clearly seen. If I didn't do it and didn't set the serials field in inspector, I would not know it until program tries to use it, and it would be just harder to know. Throwing argument null exception at this point is just a hobby of mine. Next is update method. TMP text class has one of variables inside that defines displayed text. It is accessed by following variable with dot and typing text. Equal sign is here to assign or set the value of displayed text. In programming, confusingly enough, double equals signs mean equals, single equal sign is an assignment. Time.time is current game time. First time is static unity class. Static class means it can be accessed anywhere. Second time is variable inside of static class time and is value of current game time in seconds of type float. Type float is number with decimal places. After second dot, we use function toString. String is default class for text variables. String goes for sequence of characters. We can use method toString here because type float has it available. It converts number to text, which text.text variable requires for code to compile. As it is in update method, it will be called every frame. I move UI to top right and start game, but guess what, I forgot to set reference for TMP text component in script we just created. But I can see it in console as argument null exception I talked about. So I exactly know what to fix. Actually, after this error, I decided I don't wanna deal with this problem this way, so I changed code to get TMP text reference in other way. I decided to use Unity method that is available in MonoBehavior inherited class, get component, sharp bracket type, end of sharp bracket, regular brackets. Inside sharp brackets, we specify type of Unity component we want to get. Get component only works if the specified type is on the same game object. Otherwise, it will set value to null, or in other words, nothing. I commented disable previous code by double slash. Also, I added new using at the top tmpro. It allows us to not repeat it in variable declaration tmp text. After writing that code, I'll return to Unity, let the code recompile, and actually don't have to do anything because get component will automatically get the reference to tmp text. So I just click play and time counter goes up, but there is one issue. Number value is displayed with too many decimal places we don't care about. Of course, I don't remember how to fix it exactly, even if I did it many times previously. So internet search begins. This is simple issue, so search result comes fast. Now I'm happy with simplest working one, typing quote 0.00 quote to in-string brackets function. Some time-lapse of me taking notes what to do in what order. If project is simple enough, and especially if I am working alone, there is little need for me for a separate system to take notes. And this way it says right in project. Funny thing about this list, and actually in any project, things to be done grow instead of shrinking while proceeding with the following points. Last thing for this video, moving player capture with input. After search and checking source code, looking through available functions and variables after dot symbol, and looking for what works and what doesn't, I slowly get an idea of what to do. Also, I debugged Unity in a funny way, literally debugging available things in input action map, and made mistake of negation equality instead of equality for null check for serialized field variable. I will skip explaining this debug log line, for now treat it as a bonus. I set Visual Studio Code input for duplicate line to default in other programs, Ctrl+D. Then I experiment a bit to get input values. If issue is simple, I don't mind just blind trying different options till I get working result. And after I get proper input from keyboard, I start working on this input, changing game state properly. In this case, player position. This is the final code to get player moving. Code is still basic and dumb, but this will be fixed later. Let's walk through new things in this script. At top, we add new serialized field variable of type float, so we can change it in inspector in both edit and playout mode to regulate how fast we move. Input action reference is single input type reference, like jump button, set of input buttons. I need to set it in inspector, and that's why I check for it in awake if equals null. Then throw exception on creation of mono behavior if it doesn't. We need to set it in inspector, and that's why I check for it in awake if equals null, then throw exception on creation of mono behavior if it does. We don't check for float because it is a value type, it always has a value, it cannot be null. By default, it is equal to 0. We have var type. It is translated to literal variable and it can be of any type. Its type is guessed by compiler depending on what we have on right side of equal sign or an assignment. In update function, in first line var vec2 declares variable that will be of type vector2 with ugly short name of vec2. Alright, we get the value in quite convoluted way. I needed to figure out myself as well by searching internet, trial and error, and looking what is available after dot symbol. Well, anyway, final right side of assignment is moveref.action.readValue sharp brackets vector2 normal brackets. Second line of update function uses variable mono behaviors have by default transform. It is transform component of game object to which mono behavior is attached and which every game object has. Transform variable has method translate, which means to change object position. It expects input parameter of type vector3. We create new vector3 by new operator and set its values inside brackets. It's called a constructor. It takes 3 input parameters for each axis. From previous line we get input in type of vector2, cause it has 2 axes, horizontal and vertical, but transfer position has 3 axes, horizontal, vertical and forward. Since we don't want to change vertical position of player, we don't use input value for that axis, so we just translate it by 0. Then we multiply new vector3 by our speed variable we set in inspector. I made one mistake here, which will be explained later, but this line in this forum is moving us more or less depending on how good frame rate we have. To get proper result, we would need to multiply vector3 by time.delta time, which is time frame took. Pick test in editor and we move by WASD input. This will do for this video. If you have any questions, feel free to ask in comment section. Also, if you enjoyed the video, please help me with like, subscribe or share. Thank you for watching. Peace.